Hello everyone, welcome to my channel. This is the second video of the topic of projectile motion. Okay, as for the first one, this one is slightly different with a bunch of unknown, a bunch of angle given. So, but don't worry, we will solve this one together. But first we need to look on to what the problem has given us and what are they asking us. Okay, so the problem said that a projectile is launched from point A here with the initial velocity of 250 at angle 45 with horizontal, and the projectile lands at point B here with on an inclined surface. That incline, they gave us 15 degrees incline with horizontal. They asked us to find what is the range this point R here that represent the distance travel along incline line. So it's pretty much give us what we need to solve this one. Okay, so we'll continue solving this together. Firstly, as always, we put on the reference axis y and x and gravitational acceleration here. Make sure that you always put this one before you start solving, because trust me, the sign in the equation is very important. Okay, so firstly, determine the distance in y-axis. We call it sy as usual. We put out the same equation we have been doing, and we see that distance from A to B vertically should be the r times sine 15, as like a normal triangle would be. Okay, so we know the displacement in y direction. Okay, now next thing we need to know is uy, which is the velocity in y-axis. Now we have an inclined velocity 250 in 45-degree angles. If we want the velocity purely in y-axis, we should time sine 45 degrees, and again, if we do that, the direction of the velocity will point upward. Okay, because it was moving toward the y-axis. Okay, let me here. Okay, so firstly it was here, then it was rotated, not rotated, mean distributed here. Okay, and the same goes for horizontal as well, which we continue talking about it here. Okay, sorry for the handwriting. Okay, but we will see this one more oftenly, how we distribute the velocity. Okay, now back to the question. Okay, we plug in what we know. Sy is r sine 15 degree equal to 250 sine 45, as I already mentioned, and of course the gravity is in minus sign because it points toward downward. Okay, the opposite to the positive y, we call it minus. Okay, then calculate what we know. We will left with the equation that have two unknown, distance r and the time travel t and t square. A little bit tough. Okay, so we can't do anything more than this, so we will leave it as this, called equation 1 per se. Then looking at another thing that we may know is the distance travel in horizontal axis, or Sx as usual. So put on equation Sx equal to ux times t equal to velocity in horizontal time the time needed to travel. Then Sx, okay, from A to B horizontally, it should be cos 15 degrees, okay, as the normal triangle would be. And okay, we plug in what we know. Okay, will be r cos 15 degrees equal to 250 cos 45 degrees times t. Then we left with r equal to 183 times t. Okay, as equation number 2. So two equations, two unknowns. We should be able to solve this one mathematically. So can we determine t from which equation 1 and 2? We substitute r here for equation 2 into this r here. So we left with this equation with a bunch of t, and if we calculated, rearranges, will left us with the second degree polynomial equation easily to be solved. Then put on calculation, we will get that we can drag a common term t outside, and then we have inside term here. So solve this, meaning that the value of t will be equal to 0 or 26.35 seconds. Okay, of course 0 will not be the answer here because it's not possible. Okay, so it needs 26.35 seconds to travel from A to B. Then once we know time, we will substitute in the equation 2. Then we will get a distance of roughly 4.8 kilometer. Okay, so that is the end of discussion. Hope you guys learn how to solve this one step by step from my guide, and we'll see you guys on the next question. Okay, stay tuned, so we'll see what kind of question we will be dealing with. Okay, thank you again for watching, and see you in the next one.